there, scientists! Welcome back. I'm excited to see you and to do science with you again today. This is our main topic for the lesson. What is friction? Have you heard the word friction before? What's that? We are going to learn all about it today. Here are our learning goals. The first one, I can write a hypothesis about friction. Look at that word hypothesis. Have you seen that word or heard it before? Right, in Miss Kozu's video. Who watched that cool green onion video? I did, I loved it. So do you remember what she taught you about the word hypothesis? What does that word mean? You're right, it's a prediction. We will be writing predictions about friction. Okay, next learning goal. I can collect data to test my hypothesis. Have you ever heard of these words, collect data? That means we are going to gather information to check to see if our hypothesis is correct or not. That is what scientists do when they do an experiment. We get to do that today together. So fun. So before we do our experiment, we need to gather some background knowledge. That means a lot of information about our topic so that we can make sure that we are making an educated guess or prediction in our hypothesis, okay? So to get our background knowledge about friction today, we will be reading this book. It's called Motion. Push and pull, fast and slow. This book was written by Darlene Stille, and it was illustrated by Sheree. Let's read it. I wonder what we'll learn about friction in this book. Changing places. You run to catch the school bus. The bus rolls down the road. Tree branches sway in the breeze. An airplane flies up into the sky. Anything that goes from one place to another is in motion. Fun fact, there are all kinds of words to describe motion. You can run, walk, jump, dance, swim, slide, and skate. Birds soar, snakes slither, monkeys swing from tree to tree. What other motion words can you think of? Remember, motion words describe things that are moving or going. Can you think of a word that's a motion word? Good ones. Awesome. How things move. Up and down, forward and backward. Some things move in straight lines, sideways or around and around. Some things move in curved lines. Fun fact, one car travels over a hilly road. Another car travels over a winding road. Both cars are moving in curved lines. A car whizzes down the road. A baseball crashes through a window. Some things move quickly. A baby crawls across a room. A ball of yarn unwinds and rolls away. Some things move slowly. Fun fact, how fast something moves is called its speed. You can measure speed. When the needle on a car speedometer points to 60, it means that it will take 1 hour for the car to move 60 miles or 97 kilometers. So you can tell the speed of a car by the speedometer it has inside. Let's get going. A kick from your foot makes the ball scoot across the field. Stepping on the gas pedal makes the car drive away. Inertia is a property of all matter. That's like things. Inertia won't let things move unless a force gets them going. A kick is the force that makes a ball that moves a ball. A motor creates the force that moves a car. Fun fact, pushing down on the car's gas pedal adds force. It makes the car go faster and faster. Going faster and faster is called acceleration. Learning so much about moving things in this book. Your bag slips off your shoulder. What is the force that got it going? What makes yo-yos dip and water spill? Why do baseballs curve down? The Earth's gravity is the force that pulls everything down toward the ground. Have you heard of gravity before? Fun fact, things speed up as they fall. A raindrop that is close to the ground is falling faster than a raindrop high up in the sky. A rolling ball, a speeding car, a falling raindrop will keep moving until something stops them. Inertia also makes moving things keep on moving. You need to wear a seatbelt because of inertia. Suppose your car stops suddenly. Your body will keep moving forward until a force stops it. A seatbelt stops your body and keeps you safe. Inertia also keeps things moving in one direction. It takes an outside force to turn or spin something. Your bike won't turn unless you move the handlebars. Kites won't dip without wind. A baseball won't curve without gravity. The ball you kicked rolls across the grass. As the grass rubs against it, the ball slows down and stops. This rubbing is called friction. There's that word, friction. Friction is a force that makes things slow down or stop moving. So inertia gets things going, and friction is what's making it slow down or stop moving. Anything that rubs can cause friction, even air. People who design airplanes think a lot about how to keep air from slowing things down. Fun fact, you need friction to walk from one place to another. Your shoes rub against the ground. This makes friction that keeps you from sliding all over the place. So there's friction everywhere. Even air is friction. It's what makes things slow down or keep moving. Who's moving? You are on a moving bus. Some friends outside see you looking out the window and wave. Your friends outside think you are moving very fast. But what about the friend next to you? Does this friend think you are moving fast? Not at all. Fun fact, think about driving down the highway. I'll think about that. The cars in the other lanes don't seem to be moving fast when your car is moving alongside them. Have you ever thought about that? When you are in a car and you see a car next to you and you're moving, it doesn't seem like this car is moving very fast, but it is. The world is full of motion you can't sense. Even as you read this book, you are speeding through space. You are on the Earth, and the Earth is spinning around and circling the sun. Have you ever thought about that? We are even moving right now because we're on Earth. Leaves are fluttering, raindrops are falling, cars are whizzing by. Look for motion and the forces that create it in everything around you. Fun fact, it looks like the sun moves across the sky, right? Like this during the day. But that is not the case at all. The Earth is moving. As the part of the Earth that you are on turns toward the sun, it becomes day. As the same part of the Earth turns away, it becomes night. Now, that's the end of our book, Motion. Push and pull, fast and slow. So now that we have some background knowledge about friction, which is what makes things slow down when it's moving, we get to start our experiment. So to start, we need to create a data sheet. So this is what I've made for my data sheet. See, And at the top, I've made a space to put my hypothesis. Okay, so you'll need to get a piece of paper just like this. What you'll first do is draw a line at the top like this, right across. Then from that line, you'll draw a line down the middle so it looks like a T. Then right in the middle of your T, you will draw another line across. So you have a space to write your hypothesis at the top, and you have 4 empty boxes, okay? You can go ahead and pause the video here if you need to work on your data sheet. Awesome. So then we can get started writing our hypotheses. This is how the experiment will work. I will have a basketball, and what I'll do is I will use the same force to push the basketball, and I'm going to see how far it rolls. Now, I am going to roll my basketball on 4 different types of ground. Okay, I'm going to write them here. The first is carpet. Carpet. Then I'll do it on hardwood. Then I'm going outside to grass. And lastly, I will test it on concrete. So we learned in our book that what makes something slow down is friction. So what I want to know is which type of ground has the most friction and which type has the least friction. So the ground that has the least friction will not make my ball slow down very fast, and my ball will roll nice and far. So I wonder, which type of ground will my ball roll the farthest on? So we will write a hypothesis. I think the ball will roll farthest on the blank because blank. So I'm gonna think, which type of ground, carpet, hardwood, grass, or concrete, do I think has the least amount of friction where my ball can keep rolling and it will not be slowed down very quickly? What do you think? Go ahead and fill in your hypothesis. I think it's going to be, I'm going to choose hardwood. So I'll write it in hardwood. And why do I think that? I feel like hardwood is very smooth. So I'm gonna do that. I think the ball will roll farthest on the hardwood because it is smooth. Go ahead and fill in your idea. It could be similar to mine, or it could be different. So now I have my hypothesis, and it's time to do the experiment to test my hypothesis. See you soon. All right, kindergartners, here I have all of my supplies for my experiment. I have a basketball. This yardstick is how I will start my experiment. Here's my data sheet and my measuring tape to see how far my ball rolled. So I've decided that my force is going to be a 1 wrist flick. So I'm gonna try to do that same amount of force every time I roll the ball so that I can get the best and most accurate results, okay? So I'm gonna start out by flicking my wrist to roll my basketball, and I'll see how far it goes. Let's try it. So I got out my measuring tape to see how far my ball rolled on the carpet, and it looks like about 91 inches. So now I need to record my findings on my data sheet. So I'm going to be drawing in the box that says carpet because we just rolled the ball on the carpet. And I will draw exactly what I see, and I'll also write down how many inches my ball traveled. All right, kindergartners, now that we have our data for how far the ball rolled on the carpet, 91 inches, so cool. It's time to go see how far it's going to roll on hardwood. Come with me. My ball traveled 400 inches on the hardwood. Wow, that's so many. I was so surprised. But that's also really good to know that the hardwood had much less friction than the carpet did. So now I'm recording my results. Go ahead and record yours as well. Okay, otters, so I came outside. I put on a sweater because I was a little bit cold. And now it's time to do our experiment on grass. So I have my setup here with the ball and the yardstick. And I'm gonna roll the ball, okay? See you in a minute. All right, so it looks like our basketball traveled 60 inches on grass. Okay, so I'm going to make my grass. Here it is. And my grass seems to have had a lot of friction because my ball only traveled 60 inches. All right, guess I'm ready to head outside to the concrete. Now I came into the front yard and I'm ready to see how far my ball will roll on concrete. All right, let's do it. Here I have my setup and let's go. Oh no, it's going crooked. Oh. Okay, I'm gonna try again. We'll see. So everyone, it turns out the sidewalk outside of my house is slightly slanted. It's not flat. That changed the direction of my ball and made it roll sideways into the parked cars. I tried my experiment 4 times and the same thing happened each time. So what I'm going to do is measure how far it went before it turned, and we'll use those results, but we have to keep in mind that the sidewalk is slightly slanted. All right, so for this one, I'm going to have to show somehow that the ball was on the sidewalk, but it went crooked. So these are the little sidewalk squares I'm making. And I'm going to show that if here's my yardstick, right, that I started my ball rolling at, I'm gonna show kind of that my ball rolled this way and then curved down that way. And my ball ended up over here. Oh my goodness. That was so much. So, and it turned out that this length was 100. Nope. That's not correct, sorry. That's all right. When you make mistakes, just erase it and keep going. Turns out that length was 331 inches. But I wonder if it could have gone farther if it wasn't a slanted sidewalk. That's a question I have. But so now we have all of them. So carpet was 91 inches, hardwood was 400 inches, grass was 60 inches, and concrete was 331 inches, but it could have gone further had I had a nice flat surface. So, can we answer a question? Which surface did the ball roll furthest on? You tell me. Which is the largest number of inches? Right, the hardwood. 400 inches. That was really far. So our next question, which ground had the most friction? Which ground had the most friction? Because remember, the friction makes the ball slow down sooner. You're right, the grass. The grass had the most friction because the ball did not roll very far. It only rolled 60 inches. Awesome. Feel free to pause the video here, scientists, if you'd like to work on your data sheet. Otters, thank you so much for doing science with me today. I had so much fun learning all about friction. Let me know if you do this experiment at your home. I'd love to know what types of ground have the most friction and the least friction. See you next time, scientists.